Hello everyone, welcome back to my channel. Today we'll be solving Leetcode problem 3108 minimum cost walk in the weighted graph. Okay, what does the problem statement says? Problem statement says there is an undirected graph with n vertices labeled from 0 to n minus 1. Okay, and you are also given an integer n and an array edges where edges of I represents u, v and w, I, indicating that there is an edge between u and v and it has a weight called w. Okay, a walk on a graph is a sequence of vertices and edges. Okay, let's say I'm walking from 0 to 3. It contains series of edges and vertices. Okay, that is what they're saying. A walk starts and ends with a vertex, and each edge connects the vertex that comes before it and the vertex that comes after it. Okay, so they're saying like if there is a edge, that means it connects these two nodes. That is what they're trying to say. It's important to note that a walk may visit the same edge or vertex more than one. Okay, so one possible walk is I can go from here to here, I can go from 1 to 2, again I can come back. Okay, so if you see, I'm actually visiting the same node twice. Okay, I'm visiting from 0 and went to 2, and again I came back to 1, I can go back to 3. Okay, so this is that is what they're trying to say. A cost of a walk starting at node V and ending at node U and ending at node B is defined as bitwise and of weights of the edges traversed during the walk. Okay, so if I'm walking, let's say I've taken a path like this. Okay, let's say I walk from 0 to 1 and from 1 to 3. So the cost of this path is basically the bitwise and operator of all the weights of the edges. Okay, so since I've moved from 0 to 3, so the cost will be 7 bitwise operator, bitwise and of 7. Okay, so that will be the cost. Okay, whatever edges will be there in the path, we have to do basically bitwise and of all those things. Okay, and we have also given a 2D array called queries where you want to start from a vertex S and you have to end at vertex V. Okay, and for each query you need to find the minimum cost of walk starting from vertex S and vertex and ending at vertex T. Okay, if there is no such walk, then answer will be -1. Okay, so here let's take an example. You have been given a query as 0 to 3. That means you have to start at 0 and you have to end at 3. Okay, so if I start at 0, I can take a path from 0 to 1 and from 1 to 3. Okay, so the cost associated for this walk is basically 7 and bitwise operator 7, 7 and bitwise and 7, which will be, okay, let me jump back to notepad and I will explain over there. Okay, so one path would be from 0 to 1 and from 1 to 3. So the cost for associated to this path is basically 7 and 7, which will be 7 actually. Okay, so this is one path. Then other path would be I can go from 0 to 1 and from 1 to 2 and 2 to 1 and 2 to 3. Okay, so in this case the cost will be 7 bitwise operator of 1 and 7. So here the cost will be 0. Okay, so that is what you see. Sorry, here the cost will be 1. Okay, so 7 and 1 will be 7. Sorry, 7 is basically written as 101. Okay, and you are trying to do bitwise operator. Okay, let me write it down here. So what are all nodes encountered in our path? Okay, we have 7 encountered, which is 7 can be written as this. Okay, right, this is 2 power 0, this is 2 power 1, this is 2 square. So this is not 7 actually, my bad. So 7 is basically 111, and we have encountered 1, so we have to do bitwise and of these two, and again we have encountered 7 again, so we have to again do bitwise and with 7. So the final answer will be 1. Okay, so the cost associated to this path is actually 1. Okay, so we have started at 0 and we have ended at 3. Let's also take starting at 3 and ending at 4. Okay, so there is no edge connected between these two nodes, so there is no path there is no way I can reach 4 from 3. So that's the reason the cost associated to this query is -1. The cost associated to this query is 1. Okay, let's take another example and try to understand what would be the cost. Okay, so I have to start at 1 and I have to end at 2. So one path would be 0 1 to 2, which is 6. Okay, so let me note it on the paths. Okay, So what all paths possible? One path possible is basically from 1 to 2, which is having an edge of 6, so weight will be 6. Okay, so another path would be this path, which is going from 1 to 0 and 0 to 2. So in that case, the cost associated would be 15 bitwise and of 7. Okay, there is one more path available, which is basically I can go from 1 to 6 and I can come back from 2 to 1. Okay, so this is what they have explained in the query as well. Okay, I can go from 1 to 2 and I can again come back from 2 to 1. Again I can go back to 1 to 2. So it's basically 1 to 2, 2 to 1, and 2 to 1 to 2. Okay, so the cost will be 6 and 1 and 6. Okay, so 6 has been involved twice. Okay, first I went from 1 to 2 and then cost is 1, again cost is 6. Okay, so here let's in the first case the cost is 6. 15 is basically I think 4 ones. Okay, and 7 is basically 3 ones. Okay, if you do bitwise and this is 15 and this is 7, if you do bitwise and here, so it will be basically 7. Okay, so this is again higher than the previous cost. Okay, let's try to do bitwise and for 6. 6 is basically this is 6 and we have to do bitwise and with 1, right? So the cost here will be 0. So the minimum cost to reach from 1 to 2 is actually 0. Okay, so the idea is see, our aim is to do, what are we supposed to do? We have to do bitwise and, right? Whenever we are doing bitwise and of two numbers, okay, it's the resultant number will be always will let's say we are doing bitwise of and of x and y. Okay, so the result, let's say it is as z. Okay, z will always be less than or equal to x. Okay, whatever is the maximum. Okay, let's say x is the maximum. Okay, will always be lesser than uh, the max of x comma y. So what I'm trying to say is, let's say x has some set of bits. Okay, and y has some another set of bits. Okay, so whenever you are trying to do bitwise and, so if you see, if there are any bits which are set oppositely, okay, so automatically those bits will be cancelled, right? These two bits will be cancelled and it will be turned out to be 0 and rest other bits will be set. Okay, so if both the numbers have similar set of bits, then the result will be similar. So at any point of time, the result will always be either equal to any one of the value, or it will be lesser, right? So our aim is to minimize the bitwise and of all the operators, right? Our aim is to minimize bitwise and of all weights, bitwise and of a path. Okay, basically bitwise and of a path. Okay, so if a path will contain some set of weights, right? So if I has to minimize bitwise and, if so the idea is to include as many weights as possible in the given path. Okay, so whenever you are doing bitwise and with a newer set of number, it's always let's say I have x and y. If I'm trying to do bitwise and with z, it will always be lesser. Okay, so bitwise x and bitwise operator of x and y will be always greater than or equal to bitwise operator of x and y and z. Okay, so if you see, the more elements are included in my operation, okay, the the chances are more to minimize the value. Okay, so this is the idea here, to include as many weights as possible in my calculation. Okay, so if you see this graph, okay, this graph has 3 edges and 3 weights. Okay, so if you observe the solution as well, we have included all the weights in the solution in our path. As a result, we got a minimum cost. Okay, so since there is no edge between 3 and 4, in that case we'll directly return as -1. There is no way we can reach here. If you see, include as many weights as possible in our graph, in our path. Okay, I have to go from 1 to 2. Okay, so include, as I said, I include as many weights as possible. Okay, so I would say 6 and 1 and 15 and 7. Okay, this will be actually equal to 0. The reason being, 6 and 1 is actually 0. 0 bitwise and of any other number will always be 0. So that is how this solution for this is turned out to be 0. Okay, so I got and I assume that you understood the glimpse why we have to include the more number of weights in the graph. The uh, our aim is to minimize. That's the reason we are including as many numbers, as many weights possible in our solution. As a result, there will be potentially the overall weight will be minimized. Okay, so in order to do this, okay, so there are two ways. Okay, if I have to reach from 0 to 3, I should know that both the nodes are present in the same graph. So let's assume that this is one set. Okay, let's say that this is S1 and this is S2. Okay, so if both the nodes, okay, both the start and end, if both present in the same set, then only there is a minimum path possible, minimum cost possible. If both start and end, if they present in two different sets, that means there is no way I can find a path. So in that case, we'll have to return one. Okay, so the idea is to label all the nodes with a set. Okay, I will be traversing, I will be using BFS here. You can use BFS or any BFS or DFS, anything. Okay, so I will be starting at node 0 and I will be marking, I will be visiting all the nodes which are possible to visit from 0. Okay, I will first start from 0. I will reach 1, then I will try to reach all the nodes connected from 1, and so on and so forth. So while traversing in the graph, I will make sure I will mark mark all the nodes with the set ID. Okay, the moment I have visited all the nodes, then there are still few more nodes in the entire graph. Okay, the moment I reach to another node, then I will increment my set ID as, and then I will start assigning the label for those nodes. Okay, so idea is to label all the nodes. Once the labeling is done, then all I have to do is to check whether both the nodes are present in the same node or different node. If they're present in the same node, then I have to do bitwise and of all the nodes present in that particular set. Okay, if both the nodes are present in two different sets, then I have to straight away return -1. Okay, so that is the thought process. Okay, let's jump back to IDE and let's try to code it down. Okay, so our first aim is to mark, traverse the entire graph and mark the set IDs to each node. Okay, so I have to mark all the nodes in this particular graph to set 1 and I have to mark this node as set 2. Okay, okay, so so I have to define a variable, I have to define something called set it belongs to. Okay, so let's say there are n nodes. Okay, here we have n nodes. Okay, in worst case all the nodes can be disconnected. Okay, there won't be any edge from 0 to 1, there won't be any edge from 1 to 3, 2 to 1 to 2, right? In the worst case, every node will belongs to each standalone set. Okay, so that's the reason I'm just taking an array of an array to assign the set ID for each node. Okay, and yeah, let's, I also need to for better traversal in the graph, right? I will be using adjacency list and I will be remapping this edges in a better for as a adjacency list. Okay, so in order to do that, let me write a function called initiate, which will basically take the number of nodes and the edges. Okay, this function will basically create an adjacency list. Okay, so private void initiate int n and int of edges. Okay, So whatever initializations will be required for our coding, I will be having everything in one place. Okay, so just for the better readability. So first thing is to I have to initiate the adjacency list. Okay, so for that I will be defining a variable called uh, uh, variable over here saying the neighbors. Okay, just for the better readability. Okay, so uh, so what are the neighbors for node 0? Okay, so the node 0 has neighbors 1, right? Again for node 1 the neighbors are 0, 3 and 2, and along with the neighbors I will also store the corresponding weights as well. Okay, so first is to note the neighbors, along with that I should also store the weights associated to it, right? So in order to store the neighbor and the corresponding weight, okay, I will be using entry, okay, which is equivalent to a pair. Okay, so I will be importing it, uh, import java dot util dot map dot star. Okay, so it is part of map. Okay, so yeah, that is done. So I have okay, so I have basically uh, define a variable called neighbors. Now I have to populate it, right? So in order to populate it, so first I have to neighbors. Okay, so there will be, since there are n, sorry, sorry, since there are n nodes. Okay, so for all the n nodes I have to define the neighbors. Okay, so new array list of, there are total n nodes. Okay, so let me just initialize everything with new array list. Okay, init dot add new array list. Okay, now that I have defined my uh, basic structure for neighbors. Okay, now I have to add the corresponding neighbors into it, right? So in order to add the corresponding neighbors I have to iterate through my edges. Okay, for each edge in edges. Okay, so there is u, which is edge of 0, and we have v, which is edge of 1, and we have w, which is edge of 2. Okay, that is what they have defined. Like here you can see u, v and w, which is uh, the nodes, two nodes and the corresponding weight. Okay, so what I have to do for the neighbor dot, we have to add u to the neighbor of v. So first I will retrieve the adjacent list of neighbors of u, and then I will add v to it. Okay, so it is basically entry of v comma w. Okay, and then since v is neighbor of u will also be neighbor of v since it is undirected graph. So I should also add u to the neighbors of v. Okay, and the corresponding weight. Okay, now that I have prepared my adjacency list. Okay, now once the adjacency list has been prepared, now I have to traverse through the graph, and then I have to label all the nodes to a particular set. Okay, so sorry, let's define another function called, yeah, it's fine, or I can just say populate, just for better readability, populate uh, private void populate neighbors, where I'm taking n and array of edges. Just for the better readability, I am doing this. Okay, so I can just remove this, and I can, this is the place where I'm initiating, and this is the place uh, where I am basically populating all the neighbors. Okay, so here I only require the edges, and I don't require n as well, so I can remove n from here. And while initiating I don't require any edges, so I can simply remove the edges part from here. So here while initiating I will also initiate the sets, okay, which is the set, okay, set sets of is basically tell us the neighbor, what set that a particular node or vertex belongs to. Okay, now that I have populated everything, now I have to traverse through my graph and then I have to mark the sets. Okay, so what I will do is basically I have to, so I should, while I was traversing through my graph, right, I also need to keep track of what all nodes I have already visited. So for that I should also require a boolean array which will tell whether it is visited or not, is visited. Okay, so I will also populate that here. Is visited will be whatever number of nodes we have, those many, for each node I have to make a flag of it, right? So for int current node I have to, for all the nodes I will basically start at a node and then I will do the BFS from there. Okay, from current node is less than the total number of nodes and the current node plus plus. Okay, if the current node is not visited, okay, if the current node is not visited, okay, then I have to perform my BFS, correct? So then what I will do is basically, let's say I have to mark the node as visited and I should also mark the set it belongs to. Okay, visit and mark the node. Okay, so visit and mark function will basically visit all the possible nodes it can reach from this particular node and it will also mark the set it belongs to. Okay, so for that it has to take a node it belongs to, take a node from which it has to start the path, and it should also take a set id. Okay, so initially the set id will be 0, then I will be incrementing the set id and then I will pass. Okay, so this node will be marked with the set id 1 and all the nodes which can be reachable from 0 will be marked with set id as 1, right? So let me write this particular function. So private void visit and mark. Okay, so where I will be taking the current node and I will also take the set id. Okay, so in order to do the BFS, right, we will basically push that node into a queue and then we'll do, right? So I will be having a queue which will store the nodes which needs to be explored. Okay, to be explored. Okay, new linked list. Okay, so this the so I will be first adding the current node to this to say it needs to be explored. Okay, offer current node. The moment I offered it I will also mark it as visited. Okay, and I should also mark the current node with the set of the current node will be equal to the set id which I have received, right? Now I have to process the elements in the queue. Okay, while to be explored is not empty. Okay, as long as I have elements which needs to be explored, I will basically take those node. Okay, int node in process. Okay, so which will be to be explored dot poll. So I've taken the node out from the queue. So I have to pick all the neighbors of this particular node. So how do I pick all the neighbors which are among all the neighbors? So the neighbors can be you can get all the neighbors from this neighbors list. Okay, the neighbors of the node under process, get the neighbors of node under process, okay, for each neighbor, okay, for each neighbor. So each neighbor will be of this particular data type, right? So let's have this as neighbor. Let's name it as neighbor details since it contains um, both the neighbor name and the edge weight, right? So I will define a variable called neighbor as neighbor details dot get key will give you the neighbor, and there is also weight associated to it, okay. I don't need weight here because my aim is to just mark them as visited, mark the neighbors as visited, and if it is not visited, I have to mark it. I have to push the node, okay, into if it is not visited, okay. If the neighbor is not visited, okay, then I have to push it into the queue to uh, to get it processed for the node to be explored dot offer. I will be pushing the neighbor, so I should also mark it as visited of neighbor is true, and I should also mark the set it belongs to. The set of neighbor is actually the set id, okay. I have from here I came here, I marked it as visited, and I have pushed it into the queue to further process it, okay. And I've also mark a set id to it, okay. So if it is not visited, I will this process will keep on continue, and it will go here first, and then it will pick these two neighbors, and it will, since both were not visited, it will mark them as visited, and it will also push into the queue to further explore, and the next time it will pick this, since the neighbors of 3 were already visited, it doesn't do any action, okay. So we have actually marked all the nodes which can be reachable from 0, and then we have marked the set id, okay. So once uh, the next time it will go to 1, if one, since 1 was already visited, it don't do anything, it will just skip it, and it will reach to 4. Whenever it reaches to 4, since it was not visited, it will pass the set id as 2, and then it will try to mark all the nodes which can be reachable from there, okay. Now that we have marked all the nodes with the corresponding set. Now our aim is to identify the minimum weight of this particular set, which will be the minimum at this particular point of time. So we should also return the minimum weight. So let's define the data type for it, okay. Private int minimum cost, okay. Let's call it a minimum cost, okay. So minimum cost, we have defined the variable, so we should also initiate it, okay. While we are initiating, we require the queries, the number of queries, right. Minimum cost is equal to, okay, minimum cost will be equal to int dot number of queries. We will also receive a parameter called number of queries. For the number of queries we have, we should also return an array with the same length, right. So the minimum cost array will be basically new int of number of queries, okay. Now that we have minimum costs also defined, okay. Now so see, initially there is also one more property, right. If you do bitwise, if you do any number bitwise and with -1, it will always give you the same result, okay. 7 bitwise and of -1 will always be 7 itself, okay. Any number, you can take any number, because -1 will have all the bits set to 1, okay. So let me tell you here, okay, what I'm trying to say. So if you do -1, if you take -1, right, -1 binary representation contains all ones, okay. Okay, so like 32 bits, all the bits will contain -1. Okay, if you take any number and if you do bitwise and with -1, okay, you will again receive the same number, because the numbers, the bits which were already set will be preserved, because -1 contains all ones, and which were already 0 will also be preserved, because 1 and 0 will be always 0. Okay, so that's the reason if you do bitwise and with -1 it will always be same. So that's the reason we'll also populate the minimum cost with -1. Okay, minimum cost with -1, so that while we are starting, right, we'll directly, you don't have to do this, you don't have to fill it with -1. Whenever you're calculating, you can do the calculation with -1 bitwise, right? So just to have it in a single place, like I just populated it -1, so that the calculation will be a lot more easier. Okay, so as I mentioned, I have to traverse through all the nodes. Okay, so my aim is to yeah, I have to traverse through the queries, right? So, and while traversing through the query, so each query will contain two things, start and end. If start and end both belongs to the same set, then I have to return the minimum cost, like return the bitwise operator of all these things. Okay, so let me do some pre-calculation for it. Okay, so I will start from node 0. Okay, and then I will check what set it belongs to, and I will basically take all the neighbors, and then I will basically do the bitwise and of all the nodes, and I will store it in the minimum weights. Minimum weights. Okay, this is not minimum cost. Okay, we should also have um, another another array called cost. Okay, do I require this? I don't require. Yes, I do require. Okay, so this is basically cost of. Okay, this array is basically to the cost of set. Okay, so the set, what is the cost for set 1, what is the cost for set 2? Okay, so this is what it stores. Okay, ideally this should be populated with -1, because not this. Okay, you can all. Okay, so let's define the cost of is basically new int. Okay, uh, yep. So how many sets can be maximum possible, which will be equal to the number of nodes we have. So for each node can belongs to single set, right? And for each set I have to basically calculate the cost. Okay, so I will basically have the cost of in worst case it can have we can have n different sets, and for each set I should basically get the cost. Okay, okay. uh, Cost of set, let's be like, this will tell you what is the cost of the set. Cost of set 1 will be the corresponding value. Okay, so initially I populated it with minus, I should also populate it with -1. Arrays dot fill cost of set is -1. Okay, I just populated with -1, so that uh, whenever I'm doing the calculation it will be easy. Okay, so now that I have to traverse through the adjacency list. Okay, so so I have already have this thing here. Okay, uh, to traverse through my adjacency list and also get the neighbors. Okay, so let me just copy it. Okay, for each node I have to traverse through all the nodes, and I have to uh, populate the cost, right? So for each node I will basically retrieve the neighbors. Okay, see, I will see 0 is belongs, I know what set that 0 belongs to. Okay, I can get it from int let's say current set is basically the set of the current node. Okay, this will be giving the node, this will be giving the set that this node belongs to. Okay, so these all the neighbors, okay, all the neighbors of 0 will have a weight associated to it. So the weight should be included in the cost of the set, right? Okay, so what I will do is basically I should get the weight of the neighbor, right? So the weight will be neighbor details comma get value. Okay, now that I got the weight, I have to include this weight in my current set cost. Okay, the cost of the set, current set. Okay, let's just name it as set. Okay, or just we can add it as, name it as set id. Okay, because the set of the current node will give you a set id, and the cost of the set id, set id, I should basically do, I should include 7 in my the overall cost. So I have to do bitwise and, right? So this will include my current weight in the overall weight of this particular set. Okay, so then I will go to 1, and what all neighbors I have, I will take all the edges and I will include those weights in my set, right? So this way the cost of the particular set will be populated for all the nodes. Okay, for all the sets. The moment it has been populated, okay, now that I have to go through each query. Okay, now that I have to go to each query, and then I think for initiate we have to pass the length of the queries. Okay, let's, okay, uh, right, for initiate we need the length of the query, which is the number of queries. Okay, now for each query in the queries, okay, now it has two nodes. Okay, two things, one is u and one is v. Okay, if, as I told you, if set of u, sorry, set of u, if it is not equal to set of v, that means both belongs to two different sets. Okay, in that case the cost will be -1, right? Okay, so minimum cost, let's have a variable called int I. So initially I will be processing the ith query, so I will be 0 and then I will incrementing it. So if both are not equal, then the cost associated to the particular query will be -1. Okay, both belongs to two different sets. If both belongs to the same set, then it will be the cost of the particular set. Okay, if since cost of the particular set, so how do I get the cost of a particular set? Okay, so this is cost of, both belongs to the same set. Okay, then I have to get the cost of the particular set. Okay, the moment I've populated the cost for all the set, all the queries, cost associated to all the queries, then I have to return the query. So minimum cost associated to it. Okay, let's try to submit this. Okay, some syntax. Okay, let's keep the semicolon here. Some more syntax error. Okay, let's go back here. Okay, let's, if both were not equal, okay, set of u is not equal. Okay, and I think this should be fine. Let's check it out. Some more error. Okay, can't find the populate. Okay, I guess typos. Okay, yeah, I renamed it as populate neighbors. Let's rename it to populate neighbors, and it says set id is already defined. Okay, so I think this error is coming over here. Okay, so I already defined set id here, so I will define current set id. Okay, let's try to submit this. What is the error? It is minimum cost. My bad, too many typos. Okay, can't find the neighbor, the set of neighbor. Can't find the set of neighbor. My bad, typos, too many typos. Just bear with me. Okay, and yeah, that's, I think there is one more import issue. Okay, let's try to uh, resolve the import issue as well. Okay, mm, so java dot util dot map dot entry. Okay, so I should also import java dot I haven't import this entry. Okay, so I should include the static import for it, java dot util dot map dot entry. Okay, so this is been import. Okay, hopefully now, oh my bad, typo again. Okay, hopefully now this should work. Okay, let's see. Okay, variable v might, line number 36. My bad, it should be 1. Okay, just bear with me. I think yeah, perfect. I think all the typos were resolved, and the basic test cases were also solved. Okay, let's try to submit this. Yeah, all the test cases were also passed. Okay. um yep. So I hope you have understood my explanation. Okay, do subscribe to my coding channel for more such coding videos. I will be posting every day one coding problem. Yeah, thank you.